Hi everybody and welcome back for task 4.7 video. In today's video we have one learning target, and that is I can interpret the solution set of an inequality. Now we haven't learned about inequalities before, but they are very closely connected to something that we have learned before, which is called interval notation. So we are going to start by reviewing interval notation. This is going to be a review from Module 3, where we talked about increasing, decreasing, constant, domain, and range. We said that interval notation was a way for us to describe a group of numbers or a section of numbers on a graph. There are two different types of important symbols that we use for interval notation. The first type of important symbol is a bracket. We use brackets when there is a closed circle on the graph, which means when you look at the graph, you're going to see a filled in circle. The second important symbol that we use in interval notation are parentheses. And we use parentheses in two different scenarios, either when there is an open circle, which means it's a circle that's not filled in, or when there is a positive or a negative infinity on the graph, which means you're going to see an arrow on the graph. Now, what we're going to start with today is looking at how to take interval notation and make a graph, or how to take a graph and write that in interval notation. So there are three important steps to making a graph. The first important step to making a graph is to label the important numbers on your graph. The second step to making a graph is to decide whether it is an open or a closed circle. And the last important step when you're making a graph is to decide where to shade, which means you're either going to shade to the right of the number that you listed, to the left of the number that was listed that was important, or in between the two numbers that you listed that were important. So where's the important number? Do you use an open or a closed circle? And then do you shade to the right, to the left, or in between? So for each of these examples where we're asked to create a graph, I'm going to approach them that way. What are the important numbers? And then open or closed circle, shade to the right, to the left, or in between. So for the first example here, the important number in this interval, there are two of them, are negative infinity and positive 4. Now, on a number line, it's important to remember that negative infinity would be all the way to the left side of the number line, and positive infinity would be all the way to the right side of the number line. So in this case, the negative infinity is one of my important numbers. The other important number in this case is the number 4. So I'm just going to go ahead and label that in the middle of my graph somewhere. Now, my rule is that you always need to show me 3 numbers on your number line. So on your number line, you always have to show me 3 numbers. The way that I usually do that, if there aren't 3 numbers there already, which right now there's not because it's just the number 4, is I show one number that's bigger and one number that's smaller than that number that's already there. So in this case, the number that is bigger than the number 4 would be the number 5, and the number that's smaller than the number 4 would be the number 3. And as a reminder, on a number line, the smaller numbers are always on the left and the bigger numbers are always on the right. Now, the next step is to decide, do we have an open or a closed circle? In this case, because there's a bracket here, we're going to use a closed filled in circle on the number 4. And infinity goes on forever, so we're not going to put a dot there. What we're going to do is we're just going to put an arrow in that direction. The last step to showing this relationship is to decide where to shade. So this interval means we like and we want to include all of the numbers from negative infinity all the way up to the number 4, but then stop there. Don't go past the number 4. To show that, we're going to shade or color the part of the graph that's to the left of the number 4, which means it goes towards the negative infinity. And we're going to put an arrow there to show that it keeps going forever and ever and ever. Now, what that means is that the number 3, 2, 1, 0, -1, -2, -3 would all be a part of our solution set, as well as the decimals or fractions that are in between, like negative 3.5 or 2.5 or negative 10.7. So any decimals, numbers, any number in the world that's to the left of the number 4 on the number line would be part of my solution set. For the next example, again, we're going to start with the important numbers, but in this case, there are actually two important numbers, the -3 and the +5. So in this case, we would start by labeling the -3, but the number +5 would not just go right next to that number. You have to actually space things out properly. So I'm going to count up by counting by ones till I get to the number 5. So it'd be -2, -1, 0, 1, 2, 3, 4, and then 5. Now you'll notice that this time we've got way more than 3 numbers here. So since my rule is you have to have 3 numbers, you don't have to label anything extra because you've got way more than enough here. Now in this case, there's going to be a closed circle on the -3 because that's a bracket. And there's going to be an open circle on the +5 because that's a parentheses. And this interval means that we want to start from -3 and then stop at +5. So we would shade the numbers that are in between there. That means that any number in between -3 and +5 is okay with us for our solution set. Next, let's talk about -3, 5. So -3, 5 again has two important numbers, the -3 and the 5. That's the same two important numbers as last time. So I'm going to start by labeling the -3, and just like last time, since the number 5 would not be right next to that, I'm going to count up to the number 5. And then 5. Now, this time, both sides of this interval have parentheses. So I'm going to have open circles on both of those numbers, the -3 and the +5. And again, I'm going to shade in between because this interval means I want to start from -3 and stop at +5 and use all the numbers that are in between as my solution set. So I'm going to shade in between. Okay, now what if you have a graph and you want to write the interval notation? So let's talk about kind of going the other direction. The good news is that we're still going to use the same 3 steps. We're going to look for important numbers, we're going to look for whether there's open or closed circles, and then we're going to show that we wanted the numbers that are in between. So in this case, there are 2 important numbers in this first graph, the 2 and then this arrow, which means positive infinity. Now, the first number here has a closed circle. So the closed circle tells me to use a bracket. And anytime you have an infinity, you're going to use a parentheses. When we write our interval notation, it's going to go in the same order that it looks like on the number line. So it's going to start with a bracket, and then the 2, comma, infinity, and then a parentheses. You're basically just taking this visual representation and connecting it to symbols. On the next example, again, there are 2 important numbers. The 2 is first and the 5 is second. We've got a closed circle on the 2, so we're going to use a bracket, and we've got an open circle on the 5, so we're going to use a parentheses. When we write our interval notation, we're going to put bracket and then 2, comma, 5, and then parentheses. Last but not least, we're going to start with the number 2, and then we're going to have the number 5. Those are my 2 important numbers. Only this time we have 2 closed circles, so we're going to have a bracket on both sides. That means we're going to have bracket 2, comma, 5, and then another bracket. Now, one of the things we're going to ask you to do in this unit is we're going to ask you to kind of interpret what the meaning is of that open and closed circle. So let me kind of explain that, and then we're going to use that to circle the appropriate numbers here. The difference between an open and closed circle is not just what it looks like on the graph, but also what it means in terms of our solution. When we use a bracket because there's a closed circle, it means that the value at that endpoint is included in the solution set of numbers. So it means, for example, in this case, start from negative infinity and go up to the positive 4 and include the positive 4. The positive 4 is a solution to your problem. In this case, it would mean start from negative 3 and include the negative 3 as a solution, and then go up until the 5. Now you'll notice that the 5 here has an open circle. The difference is that when you use a parentheses or an open circle, it means that your number is not included in the set of numbers. So we're talking about not including that number. That means that in this case, the number 5 would not be a part of your solution. You would be able to use the number 4 and the number 4.5 and 4.6 and 4.7, but the number 5 is not allowed. I think about an open circle as literally being like a missing number. That means you're not using that number. That's why you didn't fill in the circle. So if I'm going to circle which numbers are part of my solution set, let's take a look at these options. For problem number 1 here, we would want the numbers from negative infinity to positive 4. So we're talking about the numbers that are less than the positive 4 and including the 4. So that means that when I circle these numbers, I'm going to circle the 3 and I'm going to circle the 4 because there's a closed circle there. That means I'm including the 4 in my solution set. It is part of my solution set of numbers. In the next example, I want the numbers starting from negative 3 and ending at 5, but not including the 5, so don't circle the 5. So I would circle the negative 3 because that's a closed circle, and then I would circle the negative 2 and the 4, but I'm not going to circle the 5 because that's an open circle, so it's not included. It's like saying literally skip that number. That's why we didn't fill it in. For the next example, I'm not going to circle the negative 3 because it's an open circle, and I'm not going to circle the positive 5 because it's an open circle. I'm just going to circle the numbers that would be in between, which are negative 2 and 4. For the next example, I want the numbers starting from 2 and including the 2, and then going towards infinity. So everything bigger than 2 is fine. That means I'm going to circle the 2 because it's a closed circle. And I'm going to circle everything bigger than that. So 3, 4, 5. And if this numbers list kept going, I would keep circling the numbers that are bigger. For 2, 5, I'm going to circle the 2 because it's a closed circle. It's part of my solution set. But I'm not going to circle the 5 because it is not a closed circle, so it is not part of my solution set. It's an open circle, so skip it. Literally leave it open. Don't circle it. Last but not least, we're going to circle the 2 and the 5 and everything in between. So I'm going to have a circle, 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 circle. This is a closed circle. This is a closed circle. That's why they're included in my solution set. Okay, next, let's make the connection between what we've already learned with interval notation and something new, which is called inequality notation. So for inequality notation, it is a different way of using symbols to show the relationship between numbers or groups of numbers. The first symbol is something you already know, and that would be the equal to symbol. Now, an example here would be if you wrote the statement x, which is the numbers that you're looking for, is equal to the number 2. Or let's use the number 3. By showing that x is equal to the number 3, you're basically saying 3 is the only number that satisfies this problem. 3 is the only solution. Now, there are other ways to describe solutions. There's also greater than, less than, greater than or equal to, and less than or equal to. So here's what those symbols look like. Greater than looks like this. And an example of how to use that in a mathematical statement would be to say x is greater than 3. What this means is that the numbers that you're looking for, x, are all bigger than the number 3. The next symbol that you need to know is the symbol less than. And the way that you would use that in a mathematical sentence is x is less than the number 3. What this means is that the numbers that you're looking for are all less than the number 3. Next, there's the symbol greater than or equal to, which is kind of a combination of a greater than and an equal to. You've got the greater than symbol and then a little underline, like how there's lines in the equal to. An example of using that in a mathematical sentence would be x, which is the numbers that you're looking for, are greater than or equal to the number 3. And last but not least, you've got less than or equal to, which is a combination of the less than and the equal to. And a way to use that in a mathematical sentence would be x is less than or equal to the number 3. Now, just like with inequality notation, we need to know how to represent this on a number line. So it's important to realize that on a number line, the numbers that are bigger are always on the right side of the number line, and the numbers that are less are always on the left side of the number line. What that means is that when you are shading on a number line, anytime you see a greater than, you're going to shade to the right. And that could be when it's a greater than or a greater than or equal to. You're going to shade to the right. And the reason is because all of the numbers that are greater are always on the right side of the number line. So if you want the numbers that are bigger than 3, you want the numbers that are on the right side of the number 3. If you ever see a less than, you're going to shade to the left. And the reason is because, again, the numbers that are smaller than a given number are always on the left side of a number line. Now, let's talk about open or closed circles. Just like when we have interval notation, we also have open and closed circles for inequalities. Now remember, a closed circle means you can be equal to that number, and an open circle means you can't. So anytime you have a greater than or a less than, so there's no little underline, there's going to be an open circle because you're not equal. And anytime you have a greater than or equal to or a less than or equal to, there's going to be a closed circle because you are going to be allowed to be equal to that number. So it's included in your solution. Now, when you're making these graphs, it's going to be the same situation as before. Step number 1 is going to be to identify the important number on the number line. Step number 2 is going to be to decide what kind of circle you're going to use. So open or closed circle. And that's going to depend on whether you're allowed to be equal or not allowed to be equal to that number. So look for the little underline that means equal. That'll tell you whether to use an open or closed circle. If it's there, you close it in, and if it's not there, you don't. Last but not least, you're going to need to shade. Now, in this case, you're going to shade to the left or to the right. We're not going to work on inequalities where you shade in between. So you're only going to ever shade in between if it's an interval, because then we can give you 2 numbers to use on your number line. And you're going to decide whether you shade to the left or the right based on whether it's a greater than or a less than. If you ever have a greater than, you're going to shade to the right. And if you ever have a less than, you're going to shade to the left. Okay, so let's try this. The first thing I'm going to do is look for an important number here. It looks like the numbers that I'm looking for, x, are going to be less than the number 2. So the number 2 is my important number. Now, just like before, I need to label 3 numbers. So I'm going to label one number smaller than that, which is 1, and one number bigger than that, which is 3. Now I need to decide if there's an open or a closed circle. In this case, there's no little underline, so I'm going to use an open circle because I'm not equal to the number 2. Last but not least, I need to decide to shade left or right. Since this is a less than symbol, I'm going to shade to the left, which means on the number line, I'm just going to shade the left side like this and put an arrow. Next, let's try x is greater than 2. Again, the important number here would be the number 2. So I'm going to label the number 2, and then I'm going to do one number that's smaller, so 1, and one number that's bigger, so 3. In this case, I'm going to use an open circle again because there's no little underline, there's no equal to, but I'm going to shade to the right this time because this greater than means shade to the right. For x, for the next one, the important number here would be 2. I want the numbers that are, in this case, less than or equal to 2. I'm going to show 2 more numbers the one that's smaller and the one that's bigger, so the 1 and the 3. In this case, I'm going to use a closed circle because now there is a little underline, so it's equal to the 2 is okay. It's okay to be equal to 2. And I'm going to shade to the left because this is a less than. Next, in the next example, you'll notice that the setup here looks a little bit different. It's important to realize that whenever you write something with inequalities, you always want the x to be first. So my advice would be here, because the x is at the end and we always want the x to be first, we're going to do a little flippy floppy. So we're just going to go ahead and switch the order here. Now, when you switch the order of the x and the 2, you also need to flip-flop the symbol to a greater than or equal to. So it started as a less than or equal to, it's switching because we're flip-flopping the order. Now the important number here is a 2, and one number that's smaller would be 1, and one number that's bigger would be 3. We're going to go ahead and use a closed circle because we're trying to graph x is greater than or equal to 2. So we're looking for the numbers that are greater than or equal to 2. And then we're going to shade to the right because the numbers that are greater than are always going to be bigger than the number 2, so on the right side of the number line. Now let's try to start with a graph and write the inequality. So my advice for you would be, whenever you're writing an inequality, the x always goes first. Always, always, always. You always start with x when you're writing an inequality. Then, just like when we made our graph, you're going to look at the important number, open, closed, which way did you shade? Same thing. So the important number here would be -1. So I'm going to write down the number -1. Now in this case, the circle here is closed and I shaded to the left. So because I shaded to the left, I'm going to use a less than symbol because left is less than. And I'm going to use an underline because there's a closed circle here. So I'm going to use an underline to say less than or equal. In the next example, the important number again is -1. And the graph looks very similar. The only difference is it's not a closed circle. So I still shaded to the left, which means I'm still going to use a less than. But I am not going to put a little underline because it is not a closed circle. In the next example, the number -1 is the important number again, but this time I shaded to the right. So because I shaded to the right, I'm going to use a greater than symbol. And since it's an open circle, I am not going to put a little underline. Last but not least, I'm going to use the number -1 as my important number. Again, I shaded to the right, so I'm going to use a greater than, but this time there is a closed circle. So I'm going to use a little underline to show that we are allowed to be equal to that number. Now, the last thing that we need to do is we need to practice translating this same solution set to interval notation and then circling the numbers that satisfy the statement. So if you wanted to take this solution set and make it interval notation, to me, the easiest way to start is by looking at the graph. So I think having a graph is really helpful. Whenever you don't have a graph, I would suggest drawing a graph. Just like we did on the other page, if you've got this graph, then in order to write this in interval notation, you would go from -infinity and stop at 2, because that was your important number. Since it's open parentheses, you're going to use open parentheses for -infinity, and since it's an open circle, you're going to use open parentheses for 2. For the next example, you would be going from 2 to +infinity. And you would use an open parentheses by the 2 since it's an open circle, and an open parentheses by the infinity because you always use open parentheses for infinity. Next, you would do -infinity because that's the left side of the number line, comma 2. And you're going to use open parentheses, but then you're going to use a bracket because there's a closed circle. For the next example, it would be 2, infinity. And you would use bracket for the 2 because it's a closed circle and parentheses for the infinity. I'm not going to do the other ones. I feel like we've done this enough times now, but I just wanted to make sure that you could see those as examples of how you would still connect this to interval notation. Last but not least, circle the numbers that satisfy the statement. So if I'm looking for all the numbers that are less than the number 2, but not including the number 2, I would circle 0 and 1 and not circle the 2 because it's not equal. If I want all the numbers that are bigger than 2, but not including 2, I would only circle 3 and 4 and not the 2 because it's an open circle. For the next one, I want all the numbers that are less than or equal to 2. So I would circle the 0, the 1, and the 2 because this time it is a closed circle. And if I want all the numbers that are greater than or equal to 2, I would circle the 2, the 3, and the 4. And this time the 2 is included because it's a closed circle. For the next few examples, x is less than or equal to -1. I would want all the numbers less than -1 and the -1 because it's a closed circle. And if it's the same situation, but it's just an open circle, the only thing that changes is I just don't circle the -1. For the next scenario, I'm going to circle the numbers that are bigger than -1 and not including the -1. So in this case, it would just be the 0. And for the last one, it would be the -1 and the 0 because now we are including the -1. It's a closed circle. All right, that is all for today. Thank you all so much for watching, and I'll see you soon for some practice.